G'day and welcome back to Buildsome, and this is our 11th presentation in the series on the timber framing code, or AS 1684, and this one's on working out the size of our hanging beams for our roof or ceiling frame. So if you look into the timber framing code, you'll find that rule 7.2.5 refers to hanging beams. The rule 7.3.7 gives us some information on where we can find the spans for hanging beams, and it points us at table 23. So rule 7.2.5.1 says that hanging beams shall support ceiling joists and the attached ceiling materials only. Hanging beams are usually at right angles or may be angled or placed off center to ceiling joists and are located directly above them. Requirements for beams supporting roof and ceiling loads are given in clauses 7.2.7 and 7.2.8. Okay, so that'll start looking at strutting beams and counter beams, etc. 7.3.7 says that the hanging beams shall be determined from span table 23 of the supplements, and that hanging beams shall support ceiling loads only via ceiling joists. The top edge of the hanging beam with a depth to breadth ratio exceeding 7 shall be laterally restrained at their supports. So if the height of the beam is more than 7 times the thickness, you have to restrain them so they don't want to fall over. So here's table 23, and you can see the information the table wants. It wants to know the ceiling load width for the hanging beam, and it wants to know the span of the hanging beam. So the span of the hanging beam. So let's have a look at our plan. So let's have a look at bedroom 1 here. The ceiling joists are running in this direction, so that the hanger has to run at 90 degrees to our ceiling joists. So the span of this hanger will be 3.5 meters, which is the internal dimension of that room. The roof load width is generally half the length or the span of the ceiling joist. So the ceiling joists are spanning from here to here. Half of 3.5 is 1750. So the roof load width for this hanging beam, which runs up here, is going to be 1750. So if you go back to a little table I've made up, the span of the hanger for bedroom 1 is 3.5. The ceiling load width is 1750. And if you need a reminder, I'll put a link to my ceiling load width video up in the top of the screen. And now we can work out our beam. So first thing, ceiling load width. We said 1750. The closest we've got to that, which is above it, is 1800. So we're going to use the 1800 column. And the span was 3.5. So we come down here till we find it's 3.4. That's close, but no good because it's under. So we have to go to 3.6. So there's our span. So that means that we can use 170 by 35 for our hanging beam. So we can put that in our table. So now we just have to work our way around the rest of the house and work out each individual beam as we go. So the next room has a span of 3.5 and a ceiling load width of 1250. We still have to use the 1800 column because there's nothing less than that. So we're going to end up with the same beam size because the span's similar. Bedroom 3, we've only got a span this time of 2.4. Ceiling load width is not going to make any difference to us. So same column, however, because our span was only 2.4, we can pick this 2.6 and we can use 120 by 35. Go down to the next one. Very similar. I know that we end up with 2.6, so we can use 120 by 35 again in that situation. The laundry span of 2.5. Again, even though our ceiling load width is only 0.9, it's not going to change because we still have to use the 1.8 column. So 120 by 35 is the hanger for that room as well. Kitchen, 3.54 metres is our span, and 1.750 is our ceiling load width. So same column again. We can get away. Just let me go back. Yep, we're still under 3.6, so we can use the 3.6 there. And 170 by 35 for that hanging beam. Now the dining room is just over 3.6, so we're going to have to go up a size. And same ceiling load width. So in this case, we actually have to can't use 3.6 because it's under, have to go to 4.1, so we're going to need to use 170 by 45. Now 170 by 45 throws up a interesting little quandary, because we want to be as efficient as possible, and this is where what we call end sections come into it. If you have a look at the end section of a piece of 170 by 45, you'll see that there's 7,650 square millimeters of timber in it. However, if you look at a piece of 190 by 35, which is the next standard size up, it only has 6,650 square millimeters. So there's less timber in this beam than there is in this beam, and with all things being right, the less timber, then the less price. So to be more efficient, we should use the 190 by 35. One, we're using less timber. Two, it should be priced less. So I'm going to say we're going to use the 190 by 35. You'll have to check your local prices to see if that's the case in your area, but that's the way we're going to work this out. So I'm going to use 190 by 35 in that case, and that just means I'm going to get, technically I could span further, but it's more efficient to use the 190 by 35. Keeping going down, the next one, the family room, is 2.740 with a ceiling load width of 1750, 1.75. We're going to have to use this time 140 by 35. And now we're starting to get some repetition going on. So this living room has the same span as the dining room, so we don't need to go back to the table. We can just use the same as what we used before. 190 by 35. And the entry is 2.4. Got a 2.4 up there and a 1750. So we can use the 120 by 35. So now we have all the different sizes of timber that we need to use for our building or for our ceiling frame. You could, if you really wanted to, just buy one size, as long as it was all 190 by 35, and use that for all of them. But as you can see, it's a fair bit of overkill, and we're trying to be as efficient as possible with our timber in these exercises. So there you go, I've worked out the timber required for our hanging beams in our frame.